So we're going to talk about the properties of radicals and what we're allowed to do and what we're not allowed to do with radicals. Now, there is one they left out, which I wish they hadn't, but I might be able to bring it up. But when we're talking about properties of radicals, please remember we're not just talking about a square root. We're talking about any root. Okay? That's why we call it an nth root. It could be any radical this will work with. So, the word product. What does the word product start to tell us? Multiplication. So when you multiply, okay, if you have nth root of A times the nth root of B, well then I'm going to get the nth root of A times B. The idea is that if you are multiplying radicals, you are allowed to multiply their insides. But it also goes with outside, inside with inside. You can never mix an outside number with an inside number, but we are allowed to multiply. So for a quick little example, if it says, let's see, the third root of x, you know what, let's throw a number in front. Let's put a 2 in the front. So it's 2 cube root of x times the cube root of 5. All right, well, first of all, do they both have the same radical? Yes or no? Do they both say a cube root? Yes, okay, so there's some work that I can do. Bless you. All right, on the inside of this one, we have an x. On the inside of this one, we have a 5. So the question to you is, can I multiply the 5 with the 2? No, this is an inside number. That's an outside number, which means what do I do with the 2 that's just kind of out there? Yeah, just leave it out there. I can't do anything with it. Outside with outside, inside with inside. So now I can work with the inside. And on the inside, what says x times 5, well, what's x times 5? That's it, I'm done. Because I can't really do anything else with this. That would be my answer. I multiply inside numbers with inside values, outside values with outside values, but they never kind of mix. Okay? The same thing goes with the quotient property. The quotient property, of course, when we hear the word quotient, that means division or divide. But we don't actually use division in our class. What represents division to us? Fraction. So let's put a fraction. There's the nth root of A over the nth root of B. And even though they're separated, what they're saying is, well, right, why have the same nth root when you can just write it once, like we're doing here, and do the division on the inside? So instead of having 2 radicals, well, why not just have 1? It also goes the other way around. If you know you can work with one number but not the other, well, then separate them so that you can work with the one that you can. Let me show you a quick example there as well. So if, for instance, we say the third root of x over the third root of 5, well, I can't really take cube roots of that 5. So the only thing I can do, they say, well, do something to it. Well, it says divide x by 5. Can you actually divide x by 5? Then the only thing I can do is turn it into just one big root and then just write x over 5 on the inside. The idea is that we are able to go back and forth between these two. But I'm only allowed to split them if I went backwards, if there's division, or if there's multiplication, I am allowed to split them up. Now, look at this first problem that we have here. There's a couple you tries there for yourself in a bit. But these are all numerical. So they're all numbers that we're going to be working with. It says cube root. Well, let me show you the list. Bless you. Is the 12 on my list of cube roots? Do you see a 12 here, everybody? No, okay. Do you see an 18 here? Then I can't do cube roots. But what I can do is, because they both say cube root, well, why write it twice? When I could just write it once, and then on the inside, I'll do 12 times 18. So get a calculator handy there. I just heard it, 216. See, but now I'm going to look. If you said it's 216, is 216 on my list? Which means, what is the cube root of 216? And that would be my answer. Comes out of that radical. So sometimes when you look at them like this, you go, oh, none of these are on my list. Yeah, but if you multiply them, they might work. All right, let's look at the next one. This one says a fourth root. That one says a fourth root. Well, why have two of them when I can just have one? And then just go 80 over 5 on the inside. Well, these are just numbers, so go for it. What's 80 divided by 5? 16, okay. Well, now the question is, can you take the fourth root of 16? Now remember, here's the meaning of that. They're asking, what number do I multiply 4 times to get a 16? That's what they're asking. Well, you also have a calculator that can do it for you. 2. There's my answer. Because 2 times 2 times 2 times 2 is 16. We have a calculator that can do that for you very quickly. All right, and then we have one with letters. Now, this one says cube root. This one says cube root. They're both x's. Well, it doesn't even matter. I can still just write one of these. So there's x squared times x to the 5th. Well, should you be writing the x twice? No, you're supposed to be writing the x how many times? With a power of what? There it is, because you're supposed to add your powers. So this counts as an answer. Or if you see a radical, that means you can write the x outside of it, but you have to make sure that you have a power involved. And what's the power going to be? 7 over 3. If you haven't figured that out, then I don't know what happened. Most of you turned in that homework where we did this, going back and forth between them. That's the idea of going back and forth between a radical and a fractional exponent. Okay? All right, take a moment. Try those U-tries right here on this side. It's going to take you too long. You have samples there anyways, so try it out. See what you can do with it. After that, we have one last thing we have to cover. All right, so once again, once you check your answers, we're all good. You always rewrite these, don't forget. So here we go. Last problems, just 2 more. This is once again review. We have done this before. Writing a radical expression in simplest form. For a denominator that is a sum or difference involving square roots, multiply both the numerator and the denominator by what we call the conjugate. Again, we've heard that word before, the idea of the conjugate of the denominator. Now, the expression a plus b plus c squared root of d, and then this one with a minus sign are conjugates of each other, where a, b, c, and d are rational numbers. This is what they mean by conjugate. If one of them is a plus, you rewrite it, and then the other one has a minus sign. So all you have to do is just change the sign in the middle. So let's review that. If I see 5 plus 2 radical 3, then what will I multiply it by for this one, Naomi? What's the conjugate of 5 plus 2? Say it again. What's the conjugate of 5 plus 2 radical 3? Yeah, that's it. That's what I would multiply it. If with the work I'm going to do later on, that would be what I multiply by. That would be the conjugate. All right, well, what if I said radical 4, not radical 4, because that works out, radical 5 minus 3, radical 7. Well, then what would be the conjugate there, Jessica. Yeah, all I'm doing is changing the sign in the middle. That's the idea. I don't have to mess with the numbers. Just all I want to know is what's a conjugate. Just change the sign in the middle. It's really all we have to do. In fact, we did it back then when we were talking about I, because remember, I is technically a radical. So when we were doing stuff like 5 plus 2I, well, what would be the conjugate for that lyric? Yeah, that would be the conjugate. Simple sign change. That's it. So when I look at these problems, one of the things that we talked about in the past is everything is okay here except that. We don't like radicals at the bottom of a fraction. So I have to get rid of it. Now, before, when the problems were a lot easier, we'll say, if I did this, so let me show you something you've done. We did this with trigonometry. If I say 3 over the radical 2, what did I multiply the bottom and the top by? And when I do this, 3 radical 2 is, well, 3 radical 2, but what did radical 2 times radical 2 become? 2, and then I'd be done. I didn't want a radical underneath. Well, when I look at this one, you can't say, well, just multiply by radical 3. The top would be fine. Look, 1 times radical 3 is radical 3, but here you would have distribution, which means 5 times radical 3 is 5 radical 3. And then what's radical 3 times radical 3? 3. So yeah, it worked out there, but you still have a radical at the bottom. And that's why that technique of what we did for when we were doing SOHCAHTOA worked nicely. But as soon as you have a plus or a minus, that's when a conjugate kicks in. So I'm going to multiply the top and the bottom, but I need the conjugate of 5 plus radical 3. So then, Jaime, what's the conjugate of 5 plus radical 3? 5 minus radical 3. And you have to do the same to the top. And so here we go. We're just going to multiply. This is old school multiplication. Algebra 1 stuff. 1 times 5 is just 5. 1 times negative radical 3 is negative radical 3. And yeah, that one's done. Because it was just a 1. Didn't do much. The bottom is the one you got to watch out for. First of all. All right, David, what's 5 times 5? And David, 5 times negative radical 3. Negative what? Yeah, because we can't do anything with it, but we'll write them next to each other. All right, well, I still got more to come here. So radical 3 times 5. So this is where it gets a little bit messy there. All right, but Noor, what's radical 3 times 5? So plus 5 radical 3. And Noor, what's radical 3 times negative radical 3? Yeah, there it is, negative 3. And remember, the whole point was I don't want to have radicals at the bottom of a fraction, and now we have 2 of them. Well, what do you notice here? Yeah, they're actually going to cancel out. So there is no radical underneath. The top says 5 minus radical 3, and the bottom now 6. Well, it's 25 minus 3, but we could just do the math now, right? 5 minus rad 3 all over. And there's my answer. My goal was I don't want to have a radical underneath. Well, I don't anymore. And that's why conjugates are needed. Conjugates will make the middle always cancel out, and then it'll make that last number come out of the radical. Okay? All right, last one. For this one, we don't like the fact that we have a radical at the bottom. But because there's a minus sign, I got to worry about the whole thing. Only because of that minus sign. So I am going to multiply the bottom and the top. All right, well, we got to talk conjugates again. So, Crystal, what's the conjugate of 3 minus radical 2? Conjugates, 5 plus 2 radical 3. Conjugate, 5 minus 2 radical 3. 5 minus 3 radical 7. Conjugate, radical 5 plus radical 3. Sorry, 3 radical 7. So what's the conjugate of 3 minus radical 2? Okay, do you notice the pattern here? I didn't change any of my numbers. What's the only thing that has to change? The symbol. So if this says 3 minus radical 2, then what's my conjugate? Yeah, radical 2. That's it. We just changed the sign in the middle. That's it. But now my multiplication can take place. So let's see, who are we going to call on for this one? All right, Giancarlo. What's 5 times 3, sir? Plus radical 2. There it is. Top is done. And remember, can I actually do the 15 plus 5? No. This has a radical next, so you can't do anything. That's it. It's done. All right, time for the bottom here, though. All right, Brandon. What is, where am I at here? What is 3 times 3? And Brandon, what's 3 times radical 2? So positive 3 rad 2. All right, and then, of course, Jacob, what is negative radical 2 times 3? And what is negative radical 2 times positive radical 2? Negative what? 2, yes. And what's going to happen to the middle, everybody? Cancel out. That's why we do conjugates. Conjugates will always cause that. That's why we use them. So then my answer, well, on the top, I have 15 plus 5, which no, you can't add, radical 2, and what's 9 minus 2? And there's my answer. Any questions? Just a warning, though. Warning, especially because BIN, you never know. They always throw random things at you. Here's a heads up. If you were to do this and work it all out, right, and you ended up with something like this. Let me use this similar one. If I ended up with 15 plus 5 radical 2 all over 10. That does not count as your final answer. Because if you notice, you got an outside number, and you have a third outside number. And what do you notice about all 3 numbers? They can all be divided by 5. They can be reduced. But you only do this if you can do it to all 3 of them. If you can only go, oh, I can only do it for those 2, then don't mess with it. But if it's all 3, you would have to write your answer as 3 plus, well, what's 5 divided by 5? And we don't write invisible ones, all over 2. And no, you can't mess with those. One's an inside, one's an outside. So you do have to watch out that sometimes keep an eye on the 3. If there is a way to reduce the 3, then reduce the 3. If you can only reduce all these 2, then just don't mess with them. Okay? All right, go for it. You have these 2 you tries to do at the bottom. And the rest of the time is for you to finish the classwork, which is up there. Most of you, I got to check the other work that you turned in, but get to it. If you have any questions, let us know.